Hello and welcome back. Today, let's talk about solving systems of equations again, but this time let's talk about solving systems of linear equations by some algebraic methods. So get some lined notebook paper handy and something to write with, because thinking and writing are the twin sisters of your mind. They go together. And let's get started. Let me share my desktop with you. You should be seeing a grid, but I'm not going to ask you to graph. Let's pick up kind of where we left off last time with solving systems by graphing. We said before that you're looking for the place where two lines intersect. So let's see, if I had this line here, let's make it that one, and then I had some other line that came through, maybe like this, and let's say it's that one right there. And if you graph them precisely, you can probably get close to the solution value, especially if it crosses like right out on a grid square and you're doing like an easy problem. But what if you graph it precisely and you get this? Where do these intersect? Well, they don't intersect at a grid line. I'm looking at this space like right in here. What is that? Like I'd have to estimate. Doesn't seem very mathematical. Like what would the solution be? Well, it's an ordered pair. What would it be? It looks like it's about 1, 2. What's the x value right there? Less than 2.5. 2.2? Maybe? I feel like I'm guessing. What's the y value? It's up 1, 2, but more than half, like 2.8. Not very precise. And isn't that the purpose of mathematics? Isn't mathematics one way of knowing things? Perhaps the way of knowing things, where the conclusions are certain? Yes, it is. So graphing may give you an idea about what's going on. You're looking for the single x and y combination that satisfies both of those equations. But the graphing method may not actually be the best analytic method. So let's talk about now how to do things with an analytic method. That was the notes from last time. All right, so let's see here. Activity number 4, solve the system of equations by an analytic method. That would mean the algebra method. Well, again, what is the solution to a system? It's the x and y values that solve both equations at the same time. Now, you can guess and check and maybe come up with an answer that might work, but that's not very mathematical. If you're in an algebra class, it's not called a guess and check class. So we got to figure out a way to do things that are a little more logical. So what have I got? I've got one equation here. Y is equal to 2x plus 1, and then y is also equal to a negative 2x plus 7. But if it's, whoops, I called that equation number 1. It's a different one. It's equation number 2. There we go. But aren't the x and y values the same? Like, wouldn't it be the same x value that solves both of them and the same y value that solves both of them? Yes, it would be. So if the y solves this one is the same as the y that solves that one, aren't these two y's equal to each other? Can't I say that y1 is equal to y2? Yeah. But what is y1? It's going to be 2x plus 1, and that must be equal to the other one, negative 2x plus 7. Oh, looky there. I can just set them equal to each other. This goes back to a kind of a simple logical statement, which says if A is equal to B and B is equal to C, the conclusion therefore is, well, A must be equal to C. You can cut out the middle. The link is here. The link is the B's. You can cut out the middle and just jump right from A is equal to C. That's kind of what I did right there. The y values are the linkage. They're the same things, right? The y1 must be equal to the y2, and so the expression must be equal to the other expression. Now I just solved this. So let's see, how would I solve it? I would add 2x to both sides, plus 2x. This cancels. I would get then 4x plus 1 is equal to 7. I would then subtract 1, minus 1, minus 1. This cancels. I get 4x is equal to 6. Now what? Oop, I'm revealing the next problem. Divide by 2, divide by 2. Can't. Maybe I should reshoot this video. Divide by 4, divide by 4, cancellations. Both are divisible by 2. I got to slow down and be patient. Both are divisible by 2. So this x value then is equal to 3/2. Look, it's a fraction. I'm not sure that if I would have estimated that by graphing it, that x is equal to 3/2 would have been something that I would have guessed. I might have guessed wrong. I might have guessed 3/4 or something like that. But I'm not finished yet. I've just got the x value. Maybe I shouldn't box it. I need to find the y value. So I come back over here and it will work for any of these. I'll do equation number 1. Y is equal to 2 times x. But what was x again? Oh, 3/2. Plus 1. And so these cancel, and so I get y then is equal to 3 plus 1, I get y is equal to 4. Now you may say, oh, what if it put it in the other one? Well, let's try it. Then the second equation, y is equal to negative 2 times x, which is 3/2, plus 7. So this is now going to cancel. The 2's and the 2's cancel, leaving yourself a negative times a 3, which is negative 3 plus 7. Isn't negative 3 plus 7 y is equal to 4? Yes, it is. See, it solves both of them. So now, the solution that solves both of them, put them all together for your final answer. It's got to be an ordered pair. Here we go. 3/2 and 4. I probably would not have been able to come to that by graphing. But that is an exact answer. It's precise, and I know it with certainty because of the algebraic methods. Good, right? So one of the methods is if you have two equations and they're both equal to y, you can just set the two things equal to each other. You can maybe even do that on a calculator. If you graph both those lines, find the intersection point. So now, let's try the next one. Solve the linear systems of equations by, what we just did is a very simple version of substitution. Okay? We're going to solve the systems of linear equations by substitution. Now, what does it mean if something is a substitute? It should be an equivalent replacement. If I'm absent from school, they find a substitute teacher. The teacher should be an equivalent replacement. I don't know that anybody can replace me. What does it mean to be equivalent? Well, okay, that's open for debate. But in mathematics, it's got to be the exact value, okay? So here's what I've got. And maybe the first thing I ought to do is I ought to label my equations. This is equation number 1, and this is equation number 2. Now, if you'll notice, I have equation number 1 already solved for the y value. What is it? Y, whatever y is, it's equal to 2x minus 1. Well, guess what? That means in the second equation, 3x plus a y value has to equal negative 9. I'm just going to replace the 2x or the y with the 2x minus 1. It's a replacement. It's an equivalent replacement. I just said it was equal to y. So in this second equation, I will replace it with its substitute, 2x minus 1. And now look, my y's are gone. Now all I've got are x's, right? That was kind of the strategy that we did with the one above. We got rid of the y's and only had x's. Now I can just solve for the x. So 3x plus 2x minus 1, this gives me, oops, telling you, must be Monday. 5x minus 1 is equal to negative 9. So if I'm going to add 1 to both sides, so plus 1, I'm going to get 5x is equal to negative 8. Now I'm going to divide both sides by 5, divide by 5. Whatever x is, it's equal to negative 8/5. I probably would have not come to that by graphing. Maybe I would have gotten 3/2, Julia. What's that, 1.5? Negative 8/5? Like, I just would have been guessing. Okay, not finished yet. Got to solve it for y. I will come back up here probably to the first one and solve it for y. Let me unclutter it a bit. Y then is equal to 2x minus 1. So y must be equal to 2 times negative 8/5 minus 1. Oh boy, fractions. Y is equal to 2 times negative 8/5, negative 16/5 minus 1. Come on, you can do this. This is like 4th and 5th grade math. Don't be scared. Be brave and be bold. So y is equal to negative 16 fifths minus how many fifths? Because the denominator has to be the same. 5. So y then is equal to negative 21 fifths. Holy smokes, I would not have been able to solve that precisely by graphing. So my final answer, negative 8 fifths, comma, negative 21 fifths. And that's exact and precise. I bet you $1 if you plug those things back up into the second one, it would solve that one too. I'll leave that to you as an exercise. Okay, so solving the linear systems by substitution gives you an analytic way to come to an answer. But notice this one was already set up. This one was already set up and solved for y. Sometimes it won't be that easy. So activity 6, solve the system by substitution. The method now is I need to solve one of the equations for one of the variables. I'm going to call this equation number 1, the first one. I'll call this one equation number 2. Be thoughtful and be easy. Look for an easy way to pick this problem up, right? Like pick up things by the easy handle. If you're going to pick up a saw or a sword or a knife or something like that, don't pick it up by the blade, pick it up by the handle, right? Don't cut yourself, pick it up by the easy thing. So what does that mean with regard to this? For example, don't write this down. This is wrong. This is not what you want to do. I'll show you an example of how not to do it, but you need to feel why not to do it this way. Let me solve equation number 1 for the x variable. It's just the first equation, the first thing. If I solved this equation for the x variable, it would be 2x, and I would subtract 5y from both sides, minus 5y minus 1. Okay? Now, to solve it for x, I'm going to divide everything through by 2. Divide this by 2, divide that by 2, divide that by 2. This cancels, which is what I want, and I get x is equal to negative 5 halves y minus 1 half. You may think that's not so bad. Well, what you're going to have to do with it is you're going to have to take this expression and replace it into that x right there. So it's going to be negative 6 times negative 5 halves y minus 1 half plus 2y is equal to 20. Now you could probably manage that because there will be some nice cancellations there. But let's just be honest. Isn't that a pain? Wouldn't you like to avoid fractions, if at all possible? Yes, you would. Tell the truth. Yes, you would. I would too. Let's not solve that first equation for the x. If I solve the first equation for the y variable, I'd have to divide everything through by 5. Does 2 divide evenly by 5? Does 1 divide evenly by 5? No, so let's not do those either. Let's move on to the second equation. If I solve the second equation for x, I would have to divide everything through by 6. Is 2 divisible by 6? Is 20 divisible by 6? Not really. So keep looking. If I solved it for y here, I'd have to divide everything through by 2. Does negative 6 divide evenly by 2? Why, yes, it does. Does 20 divide evenly by 2? Why, yes, it does. Let's use this one. So let me solve equation number 2 for the y variable. So I'm going to then add 6 to both sides, or add 6x, so plus 6x. So this cancels. I'm going to get 2y is equal to 6x plus 20. Now divide everything through by 2, divide that by 2, divide that by 2, cancellations. And now I get this very comfortable 3x plus 10. Nice. No fractions. Now what? I've got a statement for y. Where did it come from? It came from the second equation. What do I do now? You've got to take this expression for y and replace it in the first equation. Do not replace it back into the original. You're just going to go in a circle. It won't work. Okay, so I'm going to replace, this was equation number 2. Replace the expression with y from 2 into equation number 1. So equation number 1 was 2x plus 5 times the y value equals negative 1. But what is the y value? It's got to be 3x plus 10. There we go. Notice the y's are gone. Now we can finish. So 2x plus 15x plus 50, oh my goodness, the numbers are big, is equal to negative 1. Combine that, 17x plus 50 is equal to -1. Subtract 50, cancellations. 17x is equal to -51. Divide this side by 17, divide that side by 17. X is then equal to, oh my goodness, -51/17. I thought you said this was going to be an easy way, Mr. Marsh. I did, and I'm telling you the truth. -3. Try it. Take 51 divided by 17. Use the machine if you need to. Yeah, -3. Am I finished yet? No. I gotta find the y value. Where should I plug it back in to find the y value? Actually, anywhere. But I think this one right here would be the best. You could plug it back into equation number 1 or equation number 2, but I could plug it back into this version of equation number 2. Why is that? It's already solved for y. So I would come over here and go, all right, so y then is equal to 3 times -3 plus 10. So y is equal to -9 plus 10. Y is equal to 1. Now I finally put them all together. -3, comma 1. There's my solution to the system. I will bet you $1 if you plug it back into both of those, it will solve both of them at the same time. And yes, you do need to give it as an ordered pair. It needs to have parentheses. The x value first, the y value second, because it is a solution point. Okay, is there anything left? Oh, yeah. Let's talk about two things for a minute. Previously, when you had a graph, when you were solving things graphically, you had the situation where you had two lines that intersected in one spot, and that's you would get like a normal solution. There was also one where you had two lines that were parallel to each other, and this one was no solution. What does that look like when you do substitution? When you do your substitution and you get down to something like this, I don't know, x plus 7 is equal to something like, x plus 5, and you're going to subtract x from both sides, minus x, and these drop out. Both of your x's drop out, and you get 7 is equal to 5. Is that a true statement? No, that's false. Okay, so when both of your variables drop out after you do the substitution and you get a false statement that remains, it's a no solution. Okay. You also had an alternative where you had two lines that really were the same thing, and this is the x and this is the y. And so you had a line that maybe looked like this, and then you had another line which was like it was the same thing. It was right on top of it. What does that look like? You would get something like x plus 7 is equal to x plus 7. You remember this from doing just kind of the regular algebra? You would maybe subtract x, and these would cancel, and you would get 7 is equal to 7. That would be an identity. But it's not quite an identity the way that you would do it with a regular equation, because you've got two variables. This would be an infinite number of solutions. But infinity is not a solution. Not every point will work. If you have a point that sits like way over here, that doesn't solve any of them. So you can't say all points work, because they don't. Only specific ones do. But there's an infinite number of specific ones, because all the points that will solve one equation are all the same points that solve the other equation, because they're the same equation. Okie dokie. So solving equations by substitution, you're going to solve one equation for one of the variables and then substitute that equivalent expression back into the other equation. And then you will get an equation of just one variable, solve for it, and then use that value to go back and solve for the second one and make sure that you give your final answer as an ordered pair. Whew. Pretty good stuff. May your day be merry and bright, and may all your mathematics be right. Bye-bye.